The raw materials come in on this side, and the robotic arms you see down there handle the initial stages of the fuselage.
As you can see, the laser moves at incredible speed, maintaining micron-level precision even through this thick aluminum alloy. The precision of the laser welding is incredible.
Absolutely, and the speed of the riveting process is just as impressive.
The structural integrity relies heavily on this section, so the drilling pattern is critical.
Absolutely, and we must ensure the team...
The fuselage sections are now being assembled. Mia is highlighting the laser alignment system, which ensures perfect synchronization during the docking sequence.
We must maintain the tightest tolerance on these forward joints. Mia, can you run the new scanner over section 9?
Already on it. The initial data looks promising.
By optimizing the airfoil shape, we minimize turbulence and maximize the laminar flow across the surface.
The real advantage of the carbon fiber isn't just strength, it's the drastic weight reduction we achieve.
The curing cycle looks stable.
This new design increases the fuel capacity by 20%.
And these are the new distribution lines we've integrated into the structure.
This here is the oleo strut. It uses a combination of oil and compressed air to absorb the impact during landing, ensuring a smooth touchdown.
As you can see, the pressure holds steady at the set point. The warning system immediately alerts the operator.
The primary fiber runs along the upper tray, but we've routed the redundant path through this lower conduit here.
So this connects to the B-side switch then.
As you can see, the FEP is loading the OS now. We should see the green system online indicator once the BIT completes.
As you can see on the main display, this switch activates the auxiliary power unit.
Okay, zooming in on the APU schematic now.
This engine generates over 100,000 pounds of thrust.
And the fan diameter is actually larger than the fuselage of some jets.
The airflow moves through these high-pressure turbine stages, which is why the heat-resistant materials are so critical at this phase. We are getting the final material analysis now. The air flows through these stages, driving the compressor. Pay close attention to these alignment markers during the assembly sequence. The balance is critical here. As the crane lowers it, watch the load cells to ensure even weight distribution before final alignment. As you can see, the laser guidance ensures micron-level precision during the stabilization phase. The seal is critical for maintaining cabin pressure at altitude. Once it locks, we run the differential test to ensure structural integrity.
We're innovators.
Yeah.
So this multi-layer insulation really traps the air, preventing thermal bridging. See how the noise reduction mat?
Right, it feels completely deadened here.
The load is distributed evenly across these main bearers, transferring the weight directly to the foundation below.
So the R value here is crucial for maintaining the indoor temperature. This fiberglass traps the heat and prevents thermal bridging.
Should the cabin pressure change, masks will deploy automatically. Pull the mask towards you.
Place the mask over your nose and mouth and...
See this texture? It's not just for show. It's designed to withstand extreme temperatures, giving us that crucial fire rating we needed for the project.
The maximum weight for these bins is 35 pounds. As Mia is showing, they open smoothly.
And there is ample room for standard carry-on luggage.
We've integrated the new pneumatic system right here in the headrest.
The support is excellent. Let's see the full recline function now.
The beauty of this system is the fluidity.
Yeah.
We can shift from this deep magenta right into the sunset amber gradient.
This manifold ensures even pressure throughout the unit.
And this is where the compact design shines. The faucet folds completely flat.
The customization options here are key. We tailor the galley layout precisely to the airline's needs, optimizing every inch of these storage modules.
All right, Mia, start the clock now. We need to measure the flow rate through this main corridor. The target is under 3 minutes. All right, Mia, start the clock now. We need to measure the flow rate through this main corridor. The target is under 3 minutes. We've designed these redundancies to prevent a total system failure. See the orange cables?
Yes, but the diagnostics are showing an anomaly here.
So the lumbar support adjusts right here.
Ah, I see. And the tracking motion is very smooth.
Yes, fully motorized with 3 memory settings.
We're at 80% now, Mia. The data stream is normalizing.
Acknowledged. Running integrity checks on Sector 4, 95, and verified. The upload is complete.
All right, initiating the sequence now. Power bus 1 online, diagnostics running.
It's beautiful. We did it.
We're looking at the Fowler flaps extending.
The slow motion highlights the mechanical advantage and the smooth track movement before we reach the full 40 degrees.
As the pressure rises, the differential measurements here will pinpoint any anomalies.
And these ultrasonic sensors give us real-time data on the flow integrity.
The new livery wraps around the fuselage right here.
It really puts the size of these engines into perspective when you stand next to them.
As you can see, the customization options are extensive. We can place the logo here.
And the rendering clearly shows how the
So that covers the kitchen finishes and the appliance checks. Everything looks excellent.
Yes, all approvals marked. We can move to the living area.
Ensure the harness is properly secured. Mia, demonstrate the connection points.
The yellow clasp must click audibly, like this, and the green indicator confirms it's locked.
Perfect.
All right, Mia, confirm the flight control certification and system authority.
All checks complete, Alex. Parameters verified and logged.
Yeah.
All right, keep an eye on the meter as it spools up. The vibration dampeners should handle the low frequencies, but the high end will clip fast. As the tug moves her into position, we'll begin the landing gear stress tests, followed by the high frequency wing oscillation study.
The margin of error is nearly zero. The precision is unprecedented.
Confirmed. All systems are green and locked.
So the final approval requires a sign-off on the hydraulics check, as you can see here on the tablet.
And what if there is a discrepancy?
We flag it immediately before the next stage of review.
After months of preparation, the data confirms it. The 777 is officially flight ready.
That's incredible news, Alex. Well done, everyone. Everyone, meet Captain Eva Rostova and Major Kenji Tanaka.
Welcome. Your role is critical for the atmospheric re-entry sequence.
Okay, overhead checks are complete. Now confirming the FMS initialization. Route is loaded and verified. Once you confirm the performance data, we can proceed to engine start. See how the flaps are configured. It increases the camber, maximizing lift at this low speed. Now they spool up the engines, watch the thrust. The air moves faster over the curved top of the wing, creating the lift that pulls it up.
Yes, it's flying!
The ascent maneuver is peaking now. Look at the thrust vectoring. We're seeing a 20% gain.
What about the thermal load on console 4?
Adjusting the parameters now, it's stabilizing. The stabilization curve is nominal. We have a successful landing.
It's perfect, Alex. It actually worked.
The data clearly indicates a 15% improvement in performance.
And these graphs visualize the impact on the...
The journey is complete. She flies perfectly.
I know she does.
Goodbye, Alex.
Goodbye, Alex.